So good evening, everyone, and thank you for joining us. It's a great turnout this evening. We got 20 or so folks coming in, and we might get a few more. You're welcome to keep your cameras on, and you're also welcome to turn them off. In a minute, I'll ask you to mute, or I'll mute you all, just so that we don't get some extraneous noise coming in. But Austin's going to make this a dialogue, so you're free to unmute yourself to ask questions and to use the chat to ask questions. There's also a Q&A feature down at the bottom there, if that's convenient for you to use. We can kind of monitor all of that. So welcome to the first session of the, what do we call this? We call this the Institute for Human the Human Intelligence Project, the Temple Sholom Human Intelligence Project. That's what we called it. We, meaning me. Remember back when our biggest concern was that AI was going to, destroy the planet and the world as we know it? Remember back when that was our biggest concern? We kind of struggled a little bit. I did, like, do we go ahead with this adult learning class with everything that's going on in the world in Israel? And that's my dog. And I actually reached out to the other scholar, David Zwick, who's going to be teaching the rest of this course. And he had written to me and he said, I think that it's really important for us to continue with these things because we have to, Judaism is about hope, and we have to think about the day after. That doesn't mean that we're not present and very, very focused on what's going on. And I know as I look at the screen, many of you have family and friends in Israel. And Ari, I look at you and I know how impacted Naama's family is in particular, being on a kibbutz down in the south and now moved out of that area.
Me too.
And so our thoughts and our prayers and certainly our actions, as you've seen in the emails from the congregation, are very, very focused there. But it's also important to remember that Judaism is about l'chaim. It's about celebrating life and living life, and we cannot feel ourselves trapped in I don't want to use the word held hostage, but held captive by all that's going on, and not able to also proceed with Jewish learning, with Jewish life, and with connection and community. I think on one level, if we do that, then the hatred, the anti-Semitism, the terrorism, it gets a victory that we don't want to give it. So we're going to continue and do what synagogues do and do what we need to do as a synagogue with regard to what's happening in Israel and supporting our friends and community there and our community here. So with that as an introduction, and we are recording this webinar, but we'll share only the speaker screen. So if you don't speak, you won't be seen. But if you do speak, your video will be in the recording that will be shared on our YouTube page, which nobody really goes to unless they're looking for it. But you should just know that. So if you don't want to be seen, but you still want to ask a question verbally, then just turn off your camera at that point. So let me introduce Austin Zwick to you. Austin's up there. Well, I don't know where he's on your boxes, but he's in my upper left-hand corner, which I think was like the Peter Brady box, I think. So Austin Zwick is an assistant. He's a member of our congregation. His wife Maria is on our board. Their children are in our religious school. Austin is an assistant professor at Maxwell School of Citizenship and Public Affairs at Syracuse University and a senior research associate at their Autonomous Systems Policy Institute. Zwick's research focuses on public policy responses to social and economic transformation brought upon by technological change. His work has been published in many academic journals, including Planning Theory and Practice, Urban Geography, Review of Policy Research, GeoJournal, among many others. He is co-editor of the 2021 book, The Platform Economy and the Smart City, Technology and the Transformation of Urban Policy, published by McGill Queen's University Press, and he also lives here in Vancouver. In fact, Austin lives like just across the lane from me and about 10 doors down in what we call the Hood. Rabbi Brown used to live 10 doors down from me.
We were backdoor neighbors to Rabbi Brown, basically.
Right. So you can take the Jew out of the shtetl, but you can't take the shtetl out of the Jew, I guess. So he lives here in Vancouver with his family, and they're members of Temple Sholom. And we're so fortunate that Austin is here. And you think, well, he's here, but doesn't he teach at Syracuse? And Austin can probably explain some of that, as he has to me as well. The goal of this evening is not to do the Jewish part, but to really get an understanding of what is AI, what is it doing, where is it going, what are some of the issues that are raised by it, and then we'll tackle those through the Jewish values lens in the upcoming sessions once a month. coming forward in November. So with that, I'm going to turn it over to Austin and take it away.
Wonderful. Thank you, Rabbi Dan. And thank you all for having me. I have a slide deck that I'm going to show here, and that I'll walk everyone through. At any point, if you have any questions, feel free to ask them. If you wanted to make a joke or a comment, it makes it a lot more fun to do that, as opposed to just feeling like I'm lecturing to my students where no one wants to say anything. So I encourage participation. So as Rabbi Dan said, I live here in Vancouver, but I work for a university 3 time zones away in upstate New York. And thanks to the miracles of modern technology, I'm able to zoom in and be on the phone and talk to everybody, send emails, and be able to participate in the Autonomous Systems Policy Institute and work and publish research on things like AI and the other technology items while living here in Vancouver, which means I get the best of both worlds. I don't have to live in a small town in upstate New York. So what I'm talking about today is just, as Rabbi Dan said, is really just the basics. What is AI and what do you need to know about it in order to help set up some of the talks in the coming weeks? And before I really get started into all of this, I want to start thinking about this through a certain frame, through a certain paradigm. And that's really thinking about what is the impact of different technological innovations. And I set this up as a nice little 2x2 table. Just to start, and the first category being thinking about whenever there's a new technology that comes out, no matter what it is. First of all, let's consider what is the marginal change. Every time we aren't reinventing the wheel, or we're not jumping from plowshares to artificial intelligence. It's really just going for what's the next step in the evolutionary process. And so these changes of technology can either be incremental, it could be something very minor, or it could be completely transformative. On the other side, we also have to consider what are the use cases of this technology. Is it very limited? Or so can we just a few things or a few fields that it might affect? Or is it expansive? Is it everywhere? And so with that, we kind of get this 2x2 table of incremental and limited, something that is small changes, affects a few people or a few industries, might be a useful new gadget, but overall, it's not going to have that much impact on your everyday life. Limited and transformative, if you might have something that transforms a specific industry, and you see a lot of this in things like robotics, in things that are in the hard industry, where you might have giant leaps forward, but for the everyday person, you won't really even notice it. At the bottom left, something that's incremental and expansive means something that is transformative. It might be everywhere, but it's not a completely new thing. It has a limited impact, though it's everywhere. And finally, in the bottom left, we have transformative and expansive. This idea is that this technology is everywhere and it's transforming everything. And so where does artificial intelligence really fit into all of this? And just to give a few examples of what all of these technologies are, is limited incremental. We have something like wireless charging. It's neat, it's cool. You can put your phone on a little pad and it'll charge the battery, but is it really going to be that much different than plugging something in? Is it really going to be useful outside that one little use case? Not so much. Unlimited and transformative. Something like fiber optic cable it's amazing how much faster fiber optic cable is than coax cable. You have 100 times the speed, and the fact that they can get this to your individual house means your internet connection is mind-boggling, even compared to a decade ago. But fiber optic cable can't lift weights. It can't really do much of anything besides move data through these cords. So we put it firmly in that box. Incremental and expansive, LED light bulbs. LEDs used to just be something that you might see on a remote or on your VCR, something that was a little thing that lighted up. And now LEDs are built to make that giant sphere in Las Vegas, for example, that's been all over the news lately. LEDs are everywhere, but are they really that much more advanced than the light bulb? And I put a question mark here in this last box, expansive and transformative. And just to get some of your thoughts, some of your participation, what do you think goes here? Any ideas, any suggestions? Feel free to throw in the chat or come up and make a few guesses.
The internet.
Okay. This is going to be a punchline, and you just stole my punchline on at the end of the presentation. But thank you so much. Yeah, that's perfect. That is, the internet does go there, and I'll get to that later. I was trying to prime you to say AI, and but it may or may not be. And so I have a slide later that you beat me to it. But there's few things that really fall into this box. The internet being one of them. So just nailed it right off the board. So.
Somebody put mobile phones or cell phones in the chat if you're looking at the chat there.
Oh, cell phones, mobile phones. Great.
Yep.
The
Mobile
use of
phones.
photography and the use of AI in photography.
Photography is a really good example. I guess the photo could be the wheel. I see Ari put the wheel. I mean, I'm sure the wheel is a completely transformative technology and it had a lot of impacts. I think we've probably adjusted to those impacts since then, but maybe some people are still getting thrown out of a job because of the wheel. These are the types of things we need to start thinking about when it comes to AIs. Where does it fall into this paradigm?
One of the things that wasn't mentioned was AI use in the financial industry.
So it could completely transform the financial industry as well. There's a lot of different uses. And so one thing I do want to mention in today's talk is that AI is not really a single technology. It really is a family of technologies. And so that has a lot of different potential use cases, and it's a matter of those really coming into being. And I started to ask, how big of a difference is AI technology compared to what it came before it in those different fields?
Just the tea?
And so, today what I'm going to be covering is, first of all, AI and some basic definitions of what AI is, a general timeline, I say very general timeline of how AI came to be, a question of why now? Like why are you hearing about AI literally all over the place? And then I'm going to move into both techniques and limitations of artificial intelligence, and then a little bit of a wrap up. And so one thing I do want to mention with my little robot here is going to quickly turn it into a Venn diagram, because I think when a lot of people think about AI, what comes to mind is really robotics. They think of your different machines that are happening and what machines can do. But it's an overlapping field, but not quite the same thing. Robotics are really transforming industrial spaces of being able to move around, move in. But artificial intelligence have different arms, legs in order to consider different jobs. But artificial intelligence would really be the brain of that robot, which is a necessary component for it to start thinking and making sense of the world around it. But you can have a robot on I'm sure people used to have those little cars they could drive with the remote controls, and sense that as a robot. Buy them from Radio Shack, back when Radio Shack was around. So whereas artificial intelligence isn't quite the same thing, but it definitely has implications for robotics. And so that little middle area of the Venn diagram is, think of who your favorite robot from television is. Terminator, C-3PO. Feel free to throw that in the chat. They would be both people who are taking advantage of both robotics and artificial intelligence in order to have wants, wishes, desires, make its own decisions, and then use its limbs in order to actually carry out those ideas. But I do think these terms are sometimes used interchangeably. So AI in a definition. John McCarthy in 1955 is the one who's given credit for coining the term artificial intelligence. And he called it the science and engineering of making intelligent machines. It was the 1950s. This was a definition of things that we were just cutting edge on computers. Some of the computer systems that were coming out of the Cold War, they were really trying to figure out coming out of World War II, how do you advance these to the next level with those ideas? And John McCarthy did a lot of things during that era to really advance and get the foundations of AI going. But I present another definition right below it, because in 80 years or 70 years, AI has come a long way. And so I thought I would give you a textbook definition of what AI is currently. And that's the field of information science dedicated to giving software automation characteristics that simulate the cognitive abilities of the human being, applying these simulations to problem solving and manifesting the results as moving actions, written or spoken language, graphic representations, or emerging data. And so if you open up an AI textbook today, it's going to give you a definition very much like the second one you see right there. And then, but just to break that down a little bit further, who are the people thinking about AI? How are they using it? And what spaces are they using this in? And so what are the aims of AI? And I really think it can be brought down into three different groups. The first is philosophical. It's to better understand humanity and our metaphysical place in the universe. And I think this is really what Rabbi Dan was trying to bring in Dr. Zvi Zelman to talk about it in these coming weeks, to really emphasize on that. There's also this scientific understanding of AI, is to trying to create a mimic of a brain and a nervous system to really understand through modeling more about how we work as people, how a biological understanding of humans, animals, etc. And then finally, there's a technical perspective, or more of an engineering perspective. And it's just to perform useful tasks with enhanced programming and statistical techniques. This area really focuses on what can you do with the technology versus that philosophical or scientific arenas. And with this in mind, I would say a lot of my research, a lot of my work really focuses on the social and economic impacts of the technical side of the technology, but that doesn't, and I would love to engage with people, scholars, etc., who know more about the philosophical and scientific sides of the technology. And so, I know any one person, one scholar cannot give you like the full scope of what all of these aims are. So just to go back to the timeline a little bit, and we can kind of see how this has been has started to transform over decades. In the 1950s, this is really the pioneering era of AI. We really have early scientists and mathematicians begin discussing what an artificial brain would look like and what an artificial brain would do. And so John McCarthy hosted a series of conferences at Dartmouth to really get these conversations going. And there were some early machines like Arthur Samuel's machine just coined the term machine learning to describe a technique, which we'll in a minute. IBM created a program to play checkers. Alan Turing created his famous Turing test during this era of how to tell the difference between a truly artificial, when can we not like tell the difference between an artificial brain and whatnot and a human being. And so at the bottom of the screen here, you see some of the examples of the AIs that were created during this era. So Rosenblatt's perceptron, Newell, Shaw's, and Simon's logic theorists. Really, these AIs at the time were individuals or a couple individuals coming together and putting together a computer program of early AI. Oh, and that gave into the 1960s, where what's now called GoFi or good old-fashioned AI systems really came into being. And these systems really developed logical choices and decision trees. If this happens, then this happens. Or then and follow the path all the way down and then give us an output. And it's still a technique that can be used today. But it's also a technique that has some pretty severe limitations. So when you're trying to categorize something that's flying, for example, and you're like, and you give it a picture, and it's a squirrel, and you're like, wait a minute, squirrels can't fly, except for those that can. It's pretty much impossible to program every possibility into just logical frames or decision trees, and so you really don't know what to do in these kinds of situations. And I think much less things that are much more complex, like the English language, or I've heard it before as English is no more than 3 languages in a trench coat. How do you give it that kind of understanding of what different ideas and words mean? And because it started to hit these limitations of what was possible, in the 1960s, these systems gave way to what's now referred to as the AI winter. The possibilities have pretty much dried up. The lack of computing power, memory, data led funding to basically go cold from the 1970s to the early 1990s. And this doesn't mean there weren't advances, but we see these advances starting to move from individuals to much more larger universities and research laboratories. We see robotics making an advance too. Waybot, one of the first walking robots, came out during this era. And IBM invested a lot of money into Deep Blue in order to play chess during this era. It actually came out in 1997, one of the last in order to see the end of this era, as the AI winter became an AI spring. And then in the early 2000s, we started to see a steady advancement in both computing and robotics. A lot of companies started to get into space to see what they were capable of, trying to find ways to make money, stay on the cutting edge, show off some pieces of that technology. And by the 2010s, the steady advancement became a boom. So sometimes you'll hear this referred to as AI summer, but I think AI boom is more captivating because now there's an explosion in investment and innovation. And we have a lot of technology that you're probably familiar with. IBM's Watson, who was fantastic at playing Jeopardy, who was a Jeopardy champion. Facebook's Deepface, how does Facebook know whether you're in a picture or not? And be able to identify your friends and family and all of your photos. Well, that's an AI technology that goes on in the background. Google has the same thing in your Google Photos albums that can automatically identify these things. Google's AlphaGo, when that was able to master beating the Go game, the game of Go, which was almost thought to be an impossible task, was now beating world champions at playing that board game. And one that most people now use is Siri or Alexa or Google. People have these in their homes everywhere, doing voice recognition technology and trying to take you to different ideas in different orders. And so this boom is only going to be continuing as we begin to enter into what is a golden age of AI. But we've barely just begun down this process. And so what we have right now is what's called narrow AI, or ANI, so artificial narrow intelligence, or weak AI is another way that it's called, where every AI program out there is able to accomplish a single specific task with human-led training and development. It performs functions as it's programmed to do so. Now, it might be a bit of a black box, as I'll talk about in a little bit later, about exactly how it does those things or why it makes the decisions it does. But humans are very much a big part of the process. But more importantly, the AI that we have today can't do anything that it's not trained to do. You might have a great AI at chess, but it can't play checkers. You might have an AI that can tell what you're saying, but it can't go drive a car, or it can't bring multiple inputs together in order to understand something much more complex. It can't sense the environment that it's surrounded. And this is really where we're currently at with artificial intelligence. Is as long as, especially with games that have very controlled environments, where all possibilities are known, we are basically creating the best logic systems known to man, within very narrow arenas. But and I think there's still a lot more advancement to happen in that space. But that's not what people dream of. What people dream of and write books about and give talks about and start to think about what the future entails is this idea of artificial general intelligence, or AGI. Yes, I see a hand.
Hi, this is ET. Oh, Emily. I had a comment. One of the things I've noticed is that I guess from a human perspective, right now we're trying to do this because we think that a computer can do it faster and better than a human brain can, especially if it were to reach the super ASI point. Now, my comment has to do about neurodivergent population and their ability to do math pattern recognition, and like the bigger the data set sample, the easier it is for people who are neurodivergent to see those patterns that we're trying to train AIs to do. Does that sound familiar or
I'm
right?
somewhat familiar with it, but I don't want to. So I do know that there are people who
Do not
have,
go off to that tangent thinking line, basically, right?
yeah, there are people who can do amazing math in their head, who can very logically think through problems at places that are above and beyond people who don't have neurodivergencies. There's a subset of humans out there that have amazing logical powers. Were you just trying to make the analogy, or do you have a question in there?
I think I was trying to make the analogy that there
Yeah.
are, like you say, there's a group of humans who can do what we're trying to train computers to do.
That's a great analogy. It's like we have some people, we have some amazing logic machines among us, and they might not be greatly skilled outside that one way of thinking, but they have superhuman abilities within that space. And so that was a great analogy that had never that crossed my mind before. So thank you. So what I think the dream is of what a lot of people talk about is artificial general intelligence, or AGI, or strong AI is another thing that it's called. And it's able to apply many different skills, uses, and intelligences to problem solve. Bring in a lot of different information, understand the environment around it, do things that we didn't program it to do. And it's able to learn without human-directed input. And so when this comes to be, people talk about this being a huge game changer. This is what makes a lot of us question what is our own humanity when we can program to do machines that are even at this level. But even beyond that, we can think and theorize of what's called ASI, or artificial superintelligence, where these machines are able to surpass human intelligence on basically all metrics. They're able to achieve machine consciousness, have their own wants, wishes, and desires, have their own goals, have the ability to carry out those goals, and basically create a version, superhumans, if you will, or super machines that could evolutionarily leave us in the dust. But by that point, we're really into the world of science fiction. Even some people say artificial general intelligence, we may never truly achieve that, and therefore that might very well be in the world of science fiction as well, and remain in that area. But a lot of the impacts we're seeing today is on narrow artificial intelligence. So where's Google AI on the scale? I would say Google has a lot of different narrow intelligence machines, and they might be very good at what they're doing, but they're all programmed to do a very specific thing. And I think Google is a great example here, because my next slide is because Google is on one of the companies who are on the pioneer of trying to get artificial general intelligence. And so when we talk about multiple intelligences, what are we talking about here? Well, there's a theory of multiple intelligence. Howard Gardner, in his 1983 psychology book, Frames of Mind, proposed that instead of having a single general intelligence, really individuals are composed of 8 distinct intelligences that differ based on genetics and experience. He called it music, body kinesthetic, interpersonal, verbal, linguistic, logical, mathematical, naturalistic, interpersonal, visual, spatial. And talked about how different people are good at different things. They have different level of intelligence in these 8 different spaces, and how IQ tests were only really measuring people's logical, mathematical abilities as opposed to what all the things that really make them human. And so one thing before I get too far, I do want to note that this theory has never been supported by the academic community or cognitive neuroscience. They haven't found hard evidence for this, but it does provide what many people call a useful fiction. It's a useful framework to be thinking about these things. And so what Google has been trying to do is trying to bring in different types of data and merge different artificial natural intelligences to create some sort of composite intelligence in order to get to artificial general intelligence. And so maybe it can look at an environment and understand both words on a sign and music that's playing and a picture in the background and some sort of like a logic problem and fit it all together to bring all these ideas together to achieve AGI. And this is something that human beings naturally do. We use all of our context clues to understand our environment. We creatively pull from these different areas in order to solve problems and think of new solutions in order to like expand our horizons. We find natural satisfaction in these different areas. And so I would say that the world of education does use this idea of multiple intelligences quite a bit, because it is a great way to teach kids, and it might be a great way to teach a computer system as well as we strive to achieve AGI. And so, but why now? Like, why is this all happening now? And there's an acronym that's called the Dance of Artificial Intelligence, so the dance of robots, thus the dancing robot you might see here. There's a category of factors that are all coming together at the same time in order to make all of this possible. And the first one is being data. We live in an era of a deluge of data, but that wasn't always the case. Frankly, when IBM went to go try to program their first language reader back in the 1980s, they really had a hard time going out and finding large amount of words anywhere that was computerized in a way that a machine could understand. They searched far and wide. They were like, why isn't even the Bible, or in our case, the Torah, even like transcribed into data at this point? Finally, they find a data set to train their own word processing system, the language processing system. Anyone want to guess what that is? Yeah, it's one of those weird things of history where the data set they found to train their own linguistic AI was the transcripts of IBM versus the United States of when they got sued by the government for being a monopoly. That is the text of language that they based their early AI systems off of. But that's what they were working off of. And then by the early 1990s, we had the internet, and the amount of words that people then put on willingly onto the internet, the typing that they would do, the transcribing, all the different blogs, web pages that all popped up within a few decades, made all that unnecessary. The amount of information that people upload on a daily basis of photos, pictures, videos, all of the sensors that are out and in the world is creating really more data than we know what to do with. I remember back in the early 2000s in the United States, the National Security Administration, the NSA, was collecting all sorts of information about everyone because they thought they could detect the next terrorist attack. And they had these giant servers of information just collecting this data, thinking they could go through it and find some sort of signal in the massive noise of data that's out there, only to find out that they didn't really even have the tools to process all that data. There really wasn't much they could do with it. And that's where, and it would really be a couple more decades before those tools would really come into being in order to work with all of this. But now data is no longer a problem. And so we're now living in this, what about A? A stands for algorithms. I have two little kids that do ABC books. I almost feel like I should be this is how I should be teaching them is A is for algorithms. So A is computer science as a field has advanced made by leaps and bounds over the last couple of decades. The number of people who are programmed as computer scientists and computer programmers have given us all sorts of new tools and new ways to program and a skill set to be able to train both robots and artificial intelligences. And so there's a lot of money to be made working in the world of just figuring out what the best algorithm is in order to solve a problem and inventing new algorithms to figure these things out. The complexity of code has become incredibly complex. The next is networks, and the N is for networks. The power of networks is that data can be transmitted between objects at a very rapid pace. And so I'm sure you've seen images of drone fleets being like the new fireworks as they all move in unison, or do some sort of different shape or color, or how vehicles can now talk to each other. And this is all just because of things like 3G, 4G, and now 5G technology, preventing the lag of this communication between different devices. It's now almost instantaneous to share information between things. More importantly, this allows a central place to do the thinking and then control robot arms or legs from a distance with different machines. And C is for cloud. What this means is because of the cloud technology, because we have all this memory now stored online, is every time that a robot learns something or makes a mistake, it can then learn from that experience and teach all the other robots or algorithms that's on the same servers to learn from that. Now, the best analogy I have here is the black box on airplanes. Every time an airplane has gone down, crashed over the last couple of decades, there's a black box that records everything that has happened on that airplane and what was transpiring. And then the Federal Aviation Administration in the US goes and looks at these black boxes, tries to unravel what happened, figure it out, and then they change their procedures in order to prevent future airline accidents happening the same way. And sometimes this results in planes being recalled, sometimes it results in pilots being trained and updated, sometimes the software ends up being changed. And this has made the airline industry one of the safest ways to travel. Statistically, it's almost mind-boggling how safe it is now to fly compared to almost all other forms of mobility. Well, now because of the cloud, every time a vehicle makes a similar mistake, so these fleets of autonomous cars that are now entering onto the roads, every time that one of them gets into an accident, they can all learn what went wrong and change their algorithms or change their conditions in order to not make the same mistake again. And this allows the natural learning process to reach new heights and new speeds. And that brings us to E, which is exponential improvement. And so I have a slide about this, but I see a couple questions in the chat, so I will look at those real quickly. So Violetta asked, our basic human needs don't change. How can AI contribute to our well-being, quality of life, feed the poor, contribute to the world's peace, and be used for evil? Oh wait, you're hitting me with the hard questions right off the bat. That's a complicated question. And so I think this is something that I'm going to talk more about in a minute, is what can AI actually do and what are some of its shortcomings? And so what can we realistically expect from it when it comes to solving problems? And frankly, I think a lot of these things are really open-ended questions. It's really hard to know how AI is going to be able to do these things because we don't know where the technology is, where it's going, who's going to own it, what government is going to do about it as the future progresses. A lot of these questions, there's so much uncertainty about them. And I think that's one part about the exponential improvement that I'm about to show on the next slide is really starting to talk about Moore's law. And so Moore's law is the idea that it started out as an observation, kind of became a theory, and somehow became a law, however that works, is basically the speed of calculations on microprocessors are going to double every 18 months. And so notice the scale on the left on the y-axis. That's not a linear scale. That's an exponential scale. And so what we see is this pattern that has hold true for almost a couple of generations now, from mechanical to relay to vacuum tubes to transistors to integrated circuits, how exponentially faster machines are becoming and hardware is becoming. And with the 5 different processes of robotics or artificial intelligence, how much artificial intelligence learning is occurring, and therefore the pace of change is happening here. And it's one of those things that makes it so difficult to predict the future. Just think back to the early days of the pandemic, where the virus was spreading at an exponential rate. I'm sure many of you were sitting down around your kitchen tables trying to figure out what can we go do tomorrow? What will our plans for the summer look like? Or what about next year? And every day you started to get new information about the way this virus was moving and how fast it was moving, to the point where the decisions you were making literally the day before seemed completely outdated. And so week over week, I'm sure people finally just threw up their hands and the government just shut everything down just to slow down the pace of change, to slow down the virus so our government could get this under control. And unfortunately, that's not going to be what happens with AI. We are just not going to hit the shutdown button on Moore's law and say, let's just slow all of this down while we figure out how to answer all the questions that Violetta asked. And so even things that I'm going to say in this talk of where AI is today and where are we heading could very well be outdated by next year or a couple of years from now. And this is what both excites people and terrifies them at the same time, is we just don't know where this is heading and how fast it is getting there. Also, the picture in the bottom right corner, that's what AI actually looks like. It's not Terminator. It's not C-3PO. It's a computer server. That's AlphaGo right there. That's what ended up being now the Go World Champions, was rooms full of servers that look just like that, consuming lots of water to cool them down, electricity to power them, and resources just being pumping through them. A massive amounts of resources being pumped through these servers as it tries to make its decisions. And so those black boxes, you can decide for your own how scary that actually is. But it's probably not the things that what nightmares may be made of probably does not look like a black box sitting in a corner in a giant server farm. But it very well might. We might have to change we might have to change our nightmares accordingly and what we're afraid of accordingly. I see ET. Norman, I see. No. You raised your hand.
Yes, thank you, Austin. Yes, I know we could spend forever on this, and because I've been in classes where they have and things, but the basic ideas about, at this point, AI and computers understanding doesn't seem to really fit with what we would normally consider understanding, meaning we're able to utilize something for our benefit and change what we do, whereas so far AI only can respond with predetermined ways to an input. So I think, the Turing test was very interesting, but it's always done by a person behind that, doing that. And we also communicate so someone else will understand us and we can coordinate our behavior, which doesn't mean anything to a computer because they don't behave. They only, process electrons and so on so far. So how far ahead do they think we need to, these need to be to truly start to understand? Because then you're talking about autonomy, self goals, which really can become life-threatening for humans. And I wonder if you're going to talk about why some of the world's leading people like Jeffrey Hinton at U of T, where I studied, have signed, this thing to stop it. If you're going to talk about how that can become life-threatening or existential to humanity and all life, maybe.
So you brought up a lot of really great points
Yeah.
there. And so I'm gonna try mentioning one at a time.
Sure.
Because I think the first thing you talked about is AI currently. Narrow AI really does work very well within a defined area with defined problems and defined rules of the game. And this and this is something I did want to mention is that AI, the reason you see it playing checkers, chess, Go, is because these are controlled environments where there is very easy cause and effect. Nothing else in the environment changes. You can basically lay out the rules, say here's all the possible outputs of the computer system of the choices it can make. You basically, even though it might be an exponentially high set, you can do this. And I think this is one of the biggest problems of us moving from artificial narrow intelligence to artificial general intelligence is this idea of being able to even break free of that box.
Right.
Is being able to really understand the world around it. Which brings us to the next thing that you were really talking about is what does understand the world around you actually mean? Because everything is really just inputs and outputs. It doesn't attach any ideas and any values to anything. Right. And so people are worried that machines are going to do things that we think are highly unethical because they see it as the way to achieve its goals.
Right.
A good example here is from 2001: A Space Odyssey, right? Right? When the machine...
Sure, Hal.
Yeah, Hal basically decided that to complete its mission, the humans that it was carrying were basically in its way and had to eliminate them in order to fully carry out its mission.
Did you guys know that Hal, if you shift every letter one way to the right, it equals IBM?
How about
that? Was done intentionally, and that was done intentionally.
Yep.
That's super cool. I never realized that. And so, Norman, I think a big part of your question was starting to really veer into like, what does the philosophical meaning of all this mean? And I think this is one of the areas. What I was trying to say up front, I'm more on the technical side here. I talk about the social impacts of this, but there's a lot of philosophers, and I'm sure these will be great questions for the coming weeks to Dr. Zvi Talman. I'm trying to remember his last name. You can ask him, what does Judaism say about all of these? How do we start to add a ethical framework to AI? And how do we answer these questions? I think he'd probably be a better person to start to consider these things. I know there are people who work in my building who are all about trying to answer ethics of AI's questions. But it's to me, it's the uncertainty here is so high of whether we'll ever even get to that point that I'm kind of more focused on the here and now of where these technologies go.
So just to say, there's some people like Jeffrey Hinton, some people who were grandfathers in the field, they sound much more worried than you are about a relatively near future catastrophe. You sound less worried than they are.
So what I think of is I remember back in 2018, Elon Musk came up and said, you better buy your autonomous vehicle now, because when they come out next year, I'm going to raise the price even more. And then he said the same thing in 2019, and the same thing in 2020, and the same thing in 2021, and the same thing last year. And these things, as far as everyone can tell, at this point, is artificial intelligence is really starting to. There is definitely. Oh, you know what? I got my next slide on this. This is exactly going to be a great lead-in.
Good. Okay.
So I think beyond the technical side of all these things changing, a big reason of why you're hearing about this right now, I think is described by the Gartner hype curve. The Gartner hype cycle. One of the criticisms of the Gartner hype cycle is that's not actually a cycle because it's not around. It's literally just a curve. But beyond that point, it's a graphical and conceptual presentation of the maturity of emerging technologies through 5 phases, created and branded by the IT investment firm Gartner. And again, I have to add the same note here. This is not supported by academics or business research, but it is a useful fiction to describe what is happening. So at the beginning here, what we see is when there's a technology trigger, expectations start to rise very quickly of where these technologies are going and what's going to happen. And then when you end up hitting this peak of inflated expectations of these different technologies, and lots of money gets thrown at them, but then they start to not hit their goals or start not to come into being as quickly as they want to, or be as far-reaching as their salesmen doing their rise or trying to describe them as being. And so it starts to give way to this trough of disillusionment of what are these technologies actually good for. And through a lot of funding at that point dries up because these technologies just don't pan out. But that results in a rethink, a slope of enlightenment, if you will, of trying to figure out where these technologies are actually useful for and what can they do and what are more realistic timelines on getting there. And that leads to a plateau of productivity of, okay, we've now found what the use cases actually are. Are now implementing the use cases, and these technologies have now faded into the background of just normal corporate business as usual. And you might hear about them, but they're still, but it's not something that we consider particularly special. The beginning of this process is where there's a lot of hype, if you will, of how fast these things are going. And here's where the hype cycle is, according to Gartner, for different artificial intelligence technologies. Though most of them are all on this upslope right now. So the dance of robotics is generally true. That is a good story. These things are happening. But there's also this thing that's happening where this is like the internet, because you're hit my punchline before I got there, Norman. Like the internet, what we're pretty much experiencing right now is an AI bubble, if you will. We're starting down this path of the AI bubble. And so what we have to start to see is what these things are actually good for. And so these are, mind you, these are many different technologies. And I see a whole bunch of questions in the chat. One about where's ChatGPT in this graph. So that's language processing. I don't know where we can find that. Probably, I think it's probably somewhere over here. As it's starting to be, so we can start to see where ChatGPT is going to come up. I think it was a great marketing thing to release ChatGPT, but I think people are starting to realize that it's not very good at a lot of things. Ask it to write more than a page and a half. Actually, students use ChatGPT trying to turn in some essays using it. They weren't very good essays. They didn't know how to cite sources. They don't know how to pull in other material. There's some real limitations on it. All ChatGPT is trying to do is predict the next word. It's a fun, novel toy, and it might be able to collect information for you a little bit faster. But I think we're probably going to fall down this trough of disillusionment for ChatGPT very quickly. There's also a question here about Boston Dynamics with their robotic dogs and other projects. I think what Boston Dynamics is doing is really cool. They've been able to raise a lot of money. They've made a lot of great breakthroughs on robotics and making the machines become a lot more nimble. They've probably seen videos of their dogs, a deer I think they had at one point, basically try to get knocked down and be able to get back up again, be able to steady itself like a real animal. There's a lot of neat things that they're doing with self-balancing, and there will be useful applications for those technologies. But I don't, since Boston Dynamics focuses on the robotics side, as far as I know, they're not really focused on the software side of making that dog or deer think in any real way. So to me, there's limitations of that technology as well. Once you get at that brain, who knows? Maybe we'll have like artificial dogs following us around in a few years too. I saw another question or two in the chat. Is it really a plateau? I don't know. I didn't name these categories. This is from Gartner, and so how like academics have basically say no, this doesn't quite work. There's multiple peaks. Not all technologies follow this path. It doesn't really describe everything that's going on. Productivity maybe shouldn't be called a plateau. There's lots of criticisms of this thing. But what I can tell you is Gartner has made a whole lot of money with this general model trying to predict where these things are at. So there is some truth underneath all of it, just like what we were talking about with the multiple intelligences. It's useful. So, I'm gonna move on then. So what are some of the techniques of artificial intelligence? What actually composes of all these different AIs? Like, which is another way of saying, what is AI exactly? And so, I have a little comic here on the right from XKCD. When a user takes a photo, the app should check whether they're in a national park. Sure, that's easy. GIS, give me a few hours, and check whether the photo is of a bird. Okay, I'll need a research team in 5 years. And the bottom says, in computer science, it can be hard to explain the difference between what's easy to do and virtually impossible. Yes, they published this. They published this like what 5 years ago. So apparently they got the research team and can now identify birds. So this all did happen, but it's something that is easily explained. Does explain. That I think most people don't understand how difficult some of these things really are and what needs to go into it. And so what are some of these techniques? One is heuristics, and this is how to use shortcuts to prioritize a part of the search frame. And so one example is, where do we look to find a needle in a haystack? Or how do I identify this bird? What do we need to do? When it comes to a game like Go, what limits, what potential moves we can make, what mental shortcuts are we programming in the machine to make? and a limitless amount of information data that's out there, where should we even start to look to find the answer? The next is planning. And this is basically the ordering and scheduling of complex logistics. What are the goals, sub-goals, preconditions, actions, constraints, well, a more complicated decision tree, if you will, in order to create a plan of action. And so, some like architecture software would be really good for this. You want to change a few architecture things in the drawings and a few things in the drawings. Okay, how is that going to change the construction process and the requirements for it? And it will automatically reprogram all of these things for you to happen. And so, how do you build each step of a skyscraper? Artificial intelligence can help us give us the recipe for this. Actually, you can find AI recipes out there right now for all sorts of things, including food, which I hear have very mixed reviews of how good baking an AI cookie recipe is. But it can do it. It can do it. Representation, conveying concepts and informations in multiple ways. And so how does Siri know what you're asking for? This is the same idea of ChatGPT and other language processing models is basically trying to bring information together and reconvey it. So when you use different words for the same thing, the Siri or whatever system be able to blend those together in order to create meanings. And so sensing, cameras, LiDAR to see, microphone sonar to hear, tactile pressure sensors to touch, molecule chemicals detectors, smell, taste. All of these things are basically how can AI detect the world and what are the other objects in its environment, being able to make sense of the world around it. And so when we're talking about artificial intelligence, we're talking about basically using techniques like this. But you might quickly notice and quickly think that, wait, couldn't we do some of these things 5 years ago, 10 years ago, like just normal computer programming? Like, what is actually artificial intelligence? And you're not the only one with that criticism if that came to mind. Is what you start to hear from some of the AI experts in the field is that exact same thought. Jerry Kaplan at Stanford University says AI is a fabled, cobbled together from a grab bag of disparate tools and techniques, different algorithms that come together. Kate Crawford at Microsoft, also at USC, wrote a great book called Atlas of AI. AI is neither artificial nor intelligent. Shannon Valor at the University of Edinburgh, who's one of these AI ethicists, comes and says AI is human all the way down. Humans are involved in every part of this, especially with artificial neurointelligence. It's just programs doing what humans told them to do. Ian Boga asked at The Atlantic, AI is just a fancy name for a computer program. It only means making computers look like they do in the movies. And so AI, in some sense, may not actually exist. There's a truism that even people in the industry tend not to like to use the word AI because it's not really specific enough. But when it comes to funding time and filling out grant applications and going to potential people who can give them money, they will throw the word AI on everything in order to make sure that their grant applications go to the top of the pile. But despite these criticisms, that doesn't mean that there isn't something genuinely new happening here. And I think where that space new is happening is neural networks. I saw Ari nod his head there. I think Ari knows all about this. So neural networks is something that was invented in the 1950s, the statistical techniques behind these, but completely lacked the dance of robotics to really bring them into fruition. And so this neural networks is a term that I think a lot of people who work in the industry would much rather use. And the way this generally works is there's an input layer of data that can be broken down, either supervised or unsupervised learning. Machine learning usually refers to when it's more supervised, deep learning when it's unsupervised, and always says it's because they're trained. You have to actually train these things to do what you want in order for them to work. And then you have a series of hidden layers. This can be a few or this can be many as it starts to figure out what are some of the key characteristics of the input layers that help you make those decisions and figure out what this thing is. And then with all that information come together, you have an output layer of deciding what to do with that information, whether what category it fits into, do you take a right turn, a left turn, etc., based off this data input. And so, for example, this image of is this a bird or not? We can imagine one layer hidden. The first hidden layer could be, well, does it have a beak? Well, most birds have beaks, right? Like that. That's a great way to quickly identify what's a bird or not. Well, what about the duck-billed platypus, the creature that was invented by God just to mess with AI machines and try to coordinate whether these things fit into simple categories or not? There are exceptions to the rules. And so, okay, well, that if it has a beak, we can get ourselves mostly there. What about if it has feathers or not? That could be another layer. Well, birds have feathers, we know that. But what if the resolution in the image is too fuzzy to make it out? Or it's a drawing of a bird versus an actual bird itself, where does that make it not have feathers? What about another layer could be, is it in the air or not? We know that birds fly. That could be in the air. And so it's basically dissecting this picture, dissecting frames, dissecting pieces of information to finally come to its decision. And these systems are, as Ari pointed out, they're trained, they're supervised. We tell them what they should be doing in order to make these decisions. And once they're trained, once they get really good at this, then we can just let them out into the world and they can identify birds better than anyone else, or they can play Go, or they can go play chess, or they can do one simple thing better than everybody else. And this has become an incredibly powerful tool that can be used for all sorts of things. And so machine learning can end up in supervised learning is probably the biggest category of areas. Classification, of trying to classify different things, image detectors, diagnostics, customer retention. It can be supervised learning is great for regression, using mathematical techniques to figure out the probabilities of things like weather forecasting, market forecasting, population growth. On the unsupervised side, do we just give it data that's uncoded and ask it to figure out what the patterns in this? Clustering for things like marketing, recommendation systems, and customer segmentation, or trying to figure out how to reduce things to major dimensions. Figure out some unknown structure within massive amounts of data, and that helps point the way for scientists to go look. I would say this is one way they were able to find a vaccine so quickly is for COVID, is because with this massive amount of data, they were able to comb through it and use unsupervised learning to narrow down their search of where they're looking within the search frame. Reinforcement learning, of when it takes the data and is able to learn from itself, or regenerative things like game AI, robot navigation, when it's right or wrong and it keeps sometimes these machines can even play themselves, is good at certain things as well. And so this starts to cover a lot of the different ideas of what machine learning can be done in all of the different use cases. And so what are some of the jobs that we see AI currently doing? And so there used to be this 3 Ds of industry: dirty, dull, and dangerous. These are things that were done by blue-collar workers, but it's also the types of jobs that were starting to be first misplaced by just mechanization and through industrialization over the last few decades. But it's also the things that that robotics can actually do really well too. These are the places that we tend to see a lot of the jobs, the future jobs, being lost in. Jobs that are so dirty that people don't want to do them, like cleaning sewers, for example. Let's send a robot down to do that. Tasks that are incredibly repetitive. For example, at factories, or typing the same thing over and over again, or driving down highways. A lot of very dull, repetitive tasks within controlled environments, machines and AI can do perfectly well. And so we're going to see them taking over those responsibilities. Dangerous jobs, jobs that people are worried about. So some of the military things, military robots perhaps, or other construction on top of skyscrapers, for example, where people could fall and really hurt themselves. And so robots and AI are going to definitely have lots of progress in these areas. And there's a lot more contenders to add to this list too. Delicate, sometimes things are so delicate that we don't want human hands doing it. Robots being used in medicine and surgeries we see. Dexterous is places that we are so small that we can't, or so narrow that we can't move hands and fingers into. So things like nanorobots within bloodstreams is a place that we're going to see more robots move into. Jobs that are just very difficult to do, which usually means that human beings would get very either not strong enough or easily fatigued. So this is your Amazon robots in their warehouses, for example, helping people pick things faster. Domestic, a lot of domestic robots. We had someone mentioned the little Roomba vacuum earlier, helping clean things around the houses, the things that people just don't like doing, a lot of household things.
Yeah, right.
Yeah, that's a great example. And dear is usually means expensive. Things that are just very expensive for human beings to do as well. And so these are tasks that AI will probably make a lot of progress in. And they cover a lot of things, but they don't cover everything, especially things that are more human-centric. So there is a great book by Bajolfison and McAfee, some of the leaders of talking about the futurism, talking about the second machine age. And the real advice here is things like AIs and robots will let robots do what robots are good at: repetitive, dull tasks, logical thinking, whereas human beings will be very much better at doing human tasks, caring for each other, thinking creatively, raising children. And so what they predict is there being some sort of bifurcation in the future of us racing not against machines, but with machines, where we all specialize in our own things. Let's talk about some of the limitations of artificial intelligence. First of all, it's massively expensive. These machines and these programs, to program them, what it costs to run them, AI is not going to be the solution to everything, just because the price point on AI is huge. And yes, you have things like OpenAI, which is trying to make it more accessible for people to create their own AI systems. But as we talked about earlier, with narrow AI, they're only good for very limited tasks. So it might make it more accessible to some people, but in many cases, what came before it might actually be perfectly fine to solve the problem. Evolution kind of works that way. Evolution doesn't get things perfect. Evolution just gets things good enough. And so maybe at the price point, a lot of what we currently have just might be good enough. Then there's the idea of garbage in, garbage out, or like your data isn't very good. Your data is flawed. And so for things like predictive policing, for example, people commonly complain that the data that go into these systems is so biased because of historical police prejudices that the systems are completely unreliable. And this is a problem with this. Our AIs only get as good as the data we feed them. One problem with things like the generative AI systems, the things that you might see create new pictures, new videos on the internet, by basically taking your keywords, going through Google Images, and finding those Google Images, and then blending them together to give you something that's kind of new, but it's really a based off of all of these things in the past. Is that now with these AI systems are creating so much of these garbage pictures, if you will, and flooding these internet servers with them, that it's starting to read those images as part of the source material. And you quickly get down to this spiral of just not having good source data, not because there's not enough data, but because the data itself it's reading from is not very good. As you go through multiple layers of generative AI, it just gets worse and worse and worse. Then you have the frame problem, which basically anything outside the frame, it doesn't quite understand. If there's cause and effect things happening that are not explicitly listed in its environment, it's not going to get it. If something changes in its environment that's not coded for it to understand that thing has changed, it's not going to get it. And this is why, again, like they've worked very well in controlled environments like games, but they really do struggle in uncontrolled environments, such as autonomous vehicles. Why these things never quite came into fruition when they were supposed to is because the number of things that can change an environment is just so high. The sheer amount of randomness that actually exists in the universe makes trying to program every possibility and know what to do in every possibility almost virtually impossible. And as we had questions earlier about these systems have no ethical compass. They don't know what information and data means. They just make predictions based off of what they're told to, what was made in the past. And so one really good example here is that Google tried to automate its HR practices by trying to go through this pile of resumes and tell us who we should hire based on who we hired in the past. And so it did this supervised learning process. Here's who our engineers are. We think we're very good at this. We've hired the best and the brightest. We want you to find the best and brightest in this pile. And so what this AI basically came back and after going through it, it made recommendations that were basically with all names of white men. Basically, it figured out that AI said, oh, who have you hired in the past? You've hired white men. So apparently having male-sounding names is something that you're looking for. So, well, that's who we want you to hire. And Google was like, no, we don't want you to do that. We want to have a diverse applicant pool. We want to have a lot of different people. Don't take the name into account. So it sent it back. Came back, gave them a whole bunch of new names of, again, white men. So why? It figured out that men were more likely to use action verbs in their resumes than females were. So it's sort of, okay, take out the action verbs. What to do now? So it went back and gave another pile of white men. Why? Is because, apparently we noticed that you like to hire people who list sports as their hobbies, which is mostly men. And Google finally had to make a lot of adjustments to this and realized that their ethical compass was saying the system wasn't working. It was finding patterns in the data they didn't even know existed and giving them what they were asking. They didn't even realize what they were asking for. And yes, it may help them review their own ethical processes and their own biases, and therefore it's like holding up a mirror to who they were hiring in the past. But unless we have that mirror, unless we have that ethical compass, the AI in of itself might make some very bad decisions. But there's another problem, another really big problem. And that's what I call, or what's called techno-solutionism. And this goes back to the old adage of if you have a hammer, every problem looks like a nail. And this is a warning not just about AI, but about all technologies. Is that you have to know when to use the technology in order to answer the question and what questions to ask it. There are questions that you might be asking or wanting to do things that are completely inappropriate, or there might be a better response. One possible, if you go and ask an AI, what is the meaning to life, universe, and everything? It could come back with an answer like 42. It's not that might, to quote Douglas Adams, of course, because it's not designed to answer that kind of question. And that's really the human element of all of this. Is trying to figure out what our values are and how do we actually do this and when should we actually use AI. Which brings us back to our impact of technological innovation. This is where we started. Norman, thanks, Norman. You already hit my punchline here with what fits into this category is the internet. And so when we start to think about technologies that could change everything, that could be incredibly impactful, that could put people out of jobs, and change the way that we work and play and everything that we do. I think our basis of comparison is the impact of the internet. Did the internet do these things? How did we react when the internet came? What were the timelines that the internet changed these things? How did we adjust? And I think the analogy of the internet works fantastically for almost every question that we have about AI. So where does AI fit into all of this? I would say that artificial narrow intelligence at the moment fits into this incremental limited box. There are use cases, they're very for this technology. It's an incremental change compared to the algorithms before it. It might do things really better, some things that are a lot better. There's a lot more things that are coming online, but it's not the end all be all of technologies. And only the future will tell where it's going. But the future could very well be here. Artificial general intelligence could be the next internet. It could be the game changer that literally changes everything. That's both expansive and everywhere and completely transformative to every aspect of life. And thus asking some of those questions now, what does it all mean? And how do we understand Judaism within the context of artificial intelligence is a discussion that we can't wait for it to arrive before we start to figure those things out. And thus, I think the next few talks are going to be very eye-opening for all of us to understand this question. That's my talk. Thanks, everybody. If you have any questions, I'm happy to answer them. I think Rabbi Dan wants to wrap up in the next 5 minutes, but I'm happy to chat about anything you want.
Austin, that was amazing. It was really so succinct, and you covered so much in such a thorough way. Your students are so fortunate, and we are so fortunate to be your student this evening. For your students,
thank you.
Thank you. We are just about out of time. I know it's a long time to sit in front of a screen, so we thank you all for that. If it's okay with you, Austin, if you're willing to, I think some people have asked if you would share the slide deck.
Yeah, absolutely. I'll email to Rabbi Dan right after this, and feel free to.
We have everybody's email because you registered for the class, so I'll do that and send you, and I'll send a link to the recording for everybody also. So please join us. Thank you again, Austin, with some Zoom claps and jazz hands. I know you've got kids to either put to bed or to put yourself to bed because you've got to teach early in the morning. And we've got another class in November. I was actually just looking at the date and now I've made it go away. But hopefully you'll all join us for that with David Zwick Kalman. And if you missed this one or you have friends that, well, you didn't miss this one, you were here. So that class is on November 8th, AI and the Law. If you think, oh, this is really interesting, I should tell a friend, they can sign up at any time and join the process. And we thank you all for being a part of this. I hope this was a good distraction from the news of today, because there's a lot going on with the shooting now in the United States, also in Maine, another mass shooting there.
Oh, geez.
In the United States, it's just it's good to think about these things for just even a moment. So thank you all very much. Have a good evening, and an early Shabbat Shalom.
Shabbat Shalom.
Bye. Thanks.